I have my basic NestJS application that runs on my local machine that I will deploy to AWS EC2, and I will show you how step by step. We are going to console AWS. We also want to have GitHub opened. As a first step, we want to create our repository. We will call it basic NestJS application. We're going to select the right owner. Here we have an option. We might use private or public. And for this tutorial, I will proceed with public. But if you want to create a private one, check this video out so you know how to connect the private repository from the remote EC2. And our end result, we want to have this functionality working on the certain domain name zone using HTTPS. We want to initialize Git in our code base. Now we have Git initialized. All our files that we didn't commit or push are listed here. Now, when I have prepared my commit, I want to add a fresh repository as a destination. I can copy-paste all these commands and put it. Now, after refresh, I will have all my code here. Our code right now is visible to everyone in the world. Now we want to bring it to our EC2. But first, we want to create that EC2. We want to launch an instance here. We want to call it basic NestJS application. We want to select Ubuntu, and then if we want to change a specific version, we might do it in this dropdown. We not really care at this point about RAM or x86. And here we want to find something that is free, but also a little bit more powerful than micro or nano. We want to use something like small. We also want to create the key that we will use to access the remote instance. We want to put the same name. Basic NestJS application. From a security group perspective, we either can use something that is default or choose existing. And if you don't have anything, then choose create security group. You want to add a certain ports immediately. That will by default give you 80 port. And we want to allow HTTPS traffic and HTTP traffic all around the world. When we're configuring storage, it is important to use something that is free, but 8 is too small. We want to proceed with 30 gigabytes of storage. And we are not interested today in advanced settings. We can launch our instance right now. So we successfully initiated the launching of the instance. Now we want to connect to the instance remotely. So we have our key downloaded. Don't forget to run this command, because we want to define the permissions and who can access the file. For me, it was downloaded. In the download, I applied permission specification, and now we can use this command and go ahead. And this is the first time we connect to that instance. We are ready and we can start preparation of our instance to run our code. To do that, first of all, we want to configure EC2 that it has necessary libraries and packages, and then we want to deploy our code from the GitHub repository as well. As a first step, we want to ensure that all remote repositories that are connected to Ubuntu are the latest ones. Now we want to proceed to the Node.js documentation and install it. We will go to downloads, we will use 25, we will select here Linux-based distributions, and we will use Node version manager for that. And there is an error immediately because this library is not installed. Now we want to check our version, and it started to work. Okay, at this point we consider that our runtime is prepared to run our NestJS server. Let's get the code. We want to use HTTPS. Now you can here see that our basic Nest application is deployed. Now we want to install the packages. We want to look into package.json log to ensure that our dependencies in Node environment are the same. Now we want to run our application in development mode. It seems we installed it correctly, but we don't have a database on the server. Now we want to go to PostgreSQL documentation and install it. We want to go to downloads, find Linux-based distributives, Ubuntu, and then we want to install it. Now we want to access Postgres. Now we want to create database. We have created database. We want to create a new user and give them permission to use the database. We also want to switch the ownership from Postgres to products user. Now we want to check if the access works. Now we want to configure our environment variables to accommodate the changes that we have done. We can copy-paste those environment variables, but don't forget to change the database user and password to the ones that we have created already. We want to click here Ctrl-O, Enter, Ctrl-X. That's how we can save and quit the file in Nano editor. Now we want to test if our application can connect to the database. Now we want to access our application. We want to open the port because 300 is closed right now. I have several options how to do that. For this video, I'm going to change that in a security group that we have freshly created. You can find security group here. Then you can edit and bound rules. You want to add a custom TCP rule because HTTP is done on top of TCP. I want to save the rules. My instance has a generic public DNS. I can use it like this. Doesn't work. I changed to HTTP because we don't have a certificate yet. 300, my expectations it will work. I can create a product. I can delete a product. And if I want, I even can connect to my database remotely. I will use dbeaver as a client for that. We will use PostgreSQL. I want to allow my specific IP address to access the database. I only want to allow access to that database, only for mentioned user. You want to put there your address. And now I want to restart database. Now we are connected to our database. Let's see if we will see the product there. We see an error. We forgot to start the server. Now server is running. Let's see the product. It's there. How can we make our web server be accessible from this DNS? First of all, our IP address is not static. We want to make it static to ensure that we can configure Route 53, so every time we can point to the right IP address. We want to issue an IP address. Now we want to select this IP address and we want to associate it with something. We want to choose our running instance, confirm the private address and associate it. Now we know that this IP address is pointing our server, so we can do it like this. And now our connection has to be also edited, because now this is our static IP address. Fantastic. Now we want to proceed with the right domain name zone. We will go to Route 53, find our existing domain. We want to add the additional record. We will want to write here products. And in value we want to put the pointer to our IP address. We create that record. And now we can see that our IP address is attached to our domain name zone of 3rd level. While it takes time to propagate this information, we can go ahead and configure our SSL certificate. Because now we have attached an IP address, our connection was lost. Now we want to run our server. This happens because we changed the IP address, lost connection from the terminal, and the process is kinda still running there, but we cannot access the same session of the terminal, so we have to find out what is going on there, which process is blocking our port. We can see the PID. We have killed our process, and now we want to run our server. Our server is available here. Now we want to make sure that this will give us the same result. We will use Nginx and we will configure it. Ability to understand and configure Nginx will bring you in the top 5% web developers in the world. In 2021, I have written this documentation and not a lot of things has been changed. I will still use the same commands. The only change I will do is I will do it here. I will keep this empty. We want to use certbot to create our certificate. We want to use snap. Now we have our certificates and we want to configure our file. We also copy-paste SSL certificate and SSL certificate key. Now our Nginx configuration is complete. I made a couple of typos. Now we can see if our application works at the domain name zone. But before that, we need to start our server. Our application started to work at the mentioned DNS, but what will happen if I stop it? There's a solution for that. We don't need always running our code from the console, and we want to manage our process with the process manager, which is called PM2. As soon as PM2 is installed, what we want to do is we want to use our default command, but we want to wrap it into the process manager. We can also check the logs of our server. Now we see that our application works. I have an expectation that it will run on reset. So now we don't have our application stuck in the console here, and it runs. And to stop it, we can do it like this. We have a list, we can PM2 stop either number or name. We can stop the server, now it's unavailable. Now we want to be sure if something happens with our EC2 instance, our process will be recovered as soon as EC2 recovered. Now my expectations that I can do this. I will explicitly stop it. We lost connection with our server. Now we will start it. It's running. Our Nginx is started up, and our application has started up as well. Now our main priority is to be sure that our instance is running, and most of the time it will be running by default. There might be a health check issue and you will receive an email that something is wrong with your instance. But at this point we have a free EC2 instance that runs our SQL database and that is running our basic NestJS application with the basic frontend. We also can connect to our database. And this works for demoing applications, this works for MVP, this works as an acceptance server. It's definitely not something that I would suggest to use in production grade, and if you're interested in the applications that are running under load and in production, please comment in the sections below and I will record the video for that as well. Take care, have fun and enjoy your day.